Hello, welcome to the Coventry University Motion Capture Lab for Biomechanics. My name's James Shippen. In this lab we've got a 12 camera motion capture system. All 12 cameras are mounted on a rail near the top of the room. Each camera is high resolution and can operate at frequencies up to 1000 frames per second. Embedded in the floor we've got two AMTI force plates which are used to measure ground reaction forces. These force plates can be thought of as very accurate bathroom scales, but unlike bathroom scales they also measure the forces in the plane of the floor as well as normal to the floor. We use this laboratory to measure how people move and the forces that are acting upon them. The process starts by attaching about 40 retroflective markers all over the subject's body. These are seen as small white dots in the photograph. Within this lab we can measure the movement of those markers better than about plus or minus 1 millimetre. We then ask the subject to undertake the motion that we want to measure in 3 dimensions. The cameras don't actually see the subject at all they see are the markers that are attached to the subject. They're not actually photographing the image, they're actually measuring the locations of those markers. Those markers are shown in this animation as little yellow dots that are being connected by green lines. If we know where those markers are, we can then hang a skeleton effectively in between those markers and make the skeleton move as the markers move. The next step in the analysis process is to include the muscles into the skeleton model. At the moment we're using a model that contains over 600 muscles. That's most of the locomotive muscles in the human body. We then develop techniques here at Coventry to enable us to calculate the loads in each of those muscles. We can also calculate the loads in the joints and the loads in the bones. This information is often important when one's considering injury mechanisms. The software used for the animation of all of these sequences in this presentation has been written here at Coventry, and so are all the analysis procedures that are used to calculate the loads within the body. In this lab we've been involved in numerous research projects. We've undertaken research projects with professional dance companies, mainly looking at injury mechanisms and how to prevent them. We've also worked with river dance, and we've shown that every subtle changes to the dance choreography, so subtle it wouldn't be noticed by the audience, can have a marked effect on reducing the injury rates. We've analysed the fast bowlers of the England cricket team. We were looking at back injuries and how it correlates to bowling action. In fact, we analysed them just before they won the Ashes, so who knows, maybe the Ashes were actually won in Coventry. Just as we can analyse the athlete, here we're analysing the equipment used by the athlete, i.e. a new design of tennis racket. We've worked with a number of major automotive manufacturers. In this study we're examining the loads within the body and joint angles as people get into and out of the manufacturer's own vehicles and comparing it to competitor vehicles. This information was then fed back into their design process. This subject is paraplegic. He's paralysed from the mid-chest level down. A major problem with paraplegia is that bone death occurs in the legs because the legs are not being loaded. You might notice his legs are actually moving, and that's because we've attached stimulating electrodes to the muscles to get them to fire to reproduce the rowing action. Through rowing, loads are being applied back onto the bones. The question that we're addressing in this research study is how do we stimulate the leg muscles in such a way that the loads are large enough to prevent bone death, whereas not being too large such that they cause injury to the subject. I hope you found this very brief presentation of some of the biomechanical research activities at Coventry of interest. If you've got any questions, please contact me and I shall attempt to answer them. Many thanks.